Hello and welcome to this week's What Were They Thinking? Among the range of news items we have for you this week is a evisceration of somatic therapy and the nonsense that it is. The bizarre arguments that pregnancy and weed killers are related, at least in Indiana. There is a treatment for multiple food allergies, although, again, not perfect. The shrinking Y chromosome, although again not exactly something to be worried about at the moment. A new version of the Anaconda exists, leading to all sorts of claims about a new species. Admittedly very much overblown claims. The bombing of Hiroshima and Nagasaki apparently has had unexpected and very much delayed benefits. The discovery, or at least the ability to predict, where planets will form based on water. An explanation as to what would happen if the world did not have a leap day, and the interesting consequences. And finally, go home, Odysseus, you're drunk. The timestamps for these and other news items can be found in the description box below. Let's start with the nonsense that is somatic therapy. Somatic therapy, as is explained in science-based medicine, is a therapy that's meant to help people release pent-up emotions. This by itself isn't necessarily bad, but what they argue is that you can help these emotions be released by things like acupressure and hypnosis. That's bad. Yes, it's true that through things like counseling and similar, you can release the various emotions that are causing you to have symptoms of, let's say, a physical nature as a result of psychological issues. Acupuncture and similar will not do that, nor will just about any of the other ridiculous complementary, alternative, or pseudoscientific bullshit therapies that are proposed for somatic therapy. As said, it is true that it is possible to treat these by treating the underlying psychological stressor, but the key is that you treat the underlying psychological problem, not the physical problem. The physical problem is a result of the psychological issues. But the somatic therapy practitioners have instead tried to turn this on its head, claiming that it is in fact the physical symptoms that are causing you to hold on to these psychological problems. This is why somatic therapy does not work as it is described. Shifting to something that is only slightly better evidence-based, it is an argument that the smell of ripe fruit could slow down, if not outright halt, the development and growth of cancer cells. A rather ambitious claim at the best of times, let alone in this context. The researchers relied on a range of experiments, including the use of Drosophila, or the fruit fly, mice, and cell culture, so they haven't gone at this in a half-assed manner. They have, however, failed to be able to show that this is true in humans, which is a major hurdle for their claim. What they believe is happening is that diacetyl, one of the compounds that's produced both by ripening fruit and in a range of other circumstances, such as when you're fermenting food, is partly responsible for this. They have explained that in the human cells they were able to then analyze, diacetyl that was being tested as a gas inhibited the histone diacetylase. This is involved in gene expression, and so by inhibiting it, you are therefore able to prevent the expression of certain genes. Apparently, this contributed to the mice and the fruit flies' results, let's say. Of course, the sheer amount of exposure, particularly when we're talking about the fruit flies, is, well, to be frank, rather ridiculous. The exposure amounts are really just ridiculous. As such, any claim of a relationship, at least with regards to that, is, let's say, ambitious to be polite. Moving on to similar research, but arguably even worse again, it claims that women in Indiana who are pregnant have shown a significant increase in a toxic weed killer in their urine. And now, just pulling apart the headline from The Guardian, I should tell you that there's a lot of bullshit going on, but it does get worse than just what they're showing there. According to The Guardian, and this should tell you everything you need to know about the actual research itself, the 70% increase is an increase based on a study from about 10 to 12 years ago, depending on how you want to look at this. The increase is for a study that was between 2020 and 2022, building on the 2010 to 2012 study. They found that alongside an increase in number of women showing dicamba in their urine, there was an increase in the concentration. Now, this by itself is not good news until you go to the primary source, and this is where things get important, because the primary source tells us that there was some serious issues with that claim. The original or primary source says that they couldn't actually adjust for whether or not urine was collected during spraying times. That is, although it was a spray season, they don't know if the urine they were using for two distinct and separate cohorts that make up the justification for this result was or was not exposed to the dicamba, let's say on the very morning that they collected the urine, or if it had been done weeks before. Therefore, it's practically impossible to say that there is any kind of a dose-respondent relationship. All you can really say is that you found X in the urine, in this case dicamba, and that is very important. Without knowing whether or not they are exposed to this within a reasonable time frame in relationship to what they're claiming, they have no justification for the conclusions that are being touted by The Guardian, particularly when The Guardian then, for some utterly spastic reason, tries to link it to the use of glyphosate, a entirely different and very clearly a different herbicide, and they even try and claim a reduction in fetal growth and problems related to developing fetuses from glyphosate, which isn't what the researchers found. The Guardian is making a lot of claims here that are just plain wrong. Well, it's what you should expect from a piece of crap. Quite literally something that is no better than a rag used for the toilet. In news that should at least make you feel slightly better, we have the FDA approving a drug for allergies. Now, unfortunately, you shouldn't get your hopes up for this either. The reason you should not get your hopes up is that it's not going to stop you from being allergic. In fact, what it's going to do is simply reduce the likelihood of a severe reaction. And it's kinda based on a relatively small cohort study, but it has already been approved, so this is why they get away with the small cohort study. The drug is called Xolair. It's also properly labeled as omalizumab, which if you get just as tongue-tied is, well, yeah. The idea with this is that it's meant to help with, well, in the case of the study at least, children who are known to be allergic to peanuts and another food, such as milk or eggs. By exposing them to one or more allergens, they could see whether or not it had the benefit effect. The 10 medical centers they did this in found that 67% of children who were given a small amount of the things that they were allergic to could tolerate this after being given the drug. Conversely, only 7% of the control group could. So this is how we have a good idea that it works fairly well, at least a 60% reduction. You could argue it's about a 67% reduction, but accounting for the 7% in the placebo group, you generally lower that number a little bit. This, as said, will bring certain benefits, primarily that if you are exposed to an allergen unexpectedly, you have a much better chance of not having a severe reaction, For example, think of something requiring an EpiPen. It will, however, require being injected with this drug every 2 to 4 weeks. Admittedly, an injection every other week is probably a lot better than dying, so take it as you will. It's going to be a bit of an uphill battle for this from now on. Further news, although this time again, back to news that, again, should be taken skeptically, and importantly, should be analysed in the context of how important the findings actually are. Findings that just about every human placenta in an analysis contained microplastics. Microplastics are like the new buzzword for various environmental and activist groups. They scream about them, complaining that they're a sign of the world being evil and bad, not really appreciating the fact that they themselves, at least in part, will be contributing to the exact same problems. Microplastics are basically defined as tiny particles and fibers of plastic less than a micron in size. They found that in 62 tissue samples, they all contained various concentrations. It is worth pointing out that the concentrations they found were wide-sweeping, between 6.5 and 685 micrograms per gram, basically a between 1 and 100-fold difference. This therefore raises the inevitable and obvious question of what dose of this is actually a problem? And therein lies the question. It's not clear whether or not there is actually a dose-dependent relationship and what that relationship is. Further to that, there's another problem with what they found. The microplastics themselves aren't the only plastics that they identified in this study. It should be said, rather than they aren't the only plastics, it's better to say they found a wide range of plastics that make up those microplastics. Polyethylene was the most common, and this is basically the material that's used for most single-use bottles. Think of your service station or gas station Coke bottle, something like that, although generally they're made from PET-G rather than polyethylene by itself. Then they also found that there's polyvinyl chloride, nylon, polypropylene, and several other plastics. So this is not just a plastic by itself is bad, it's the wide range of plastics that they found, showing that this is likely to be an environmental issue, where the other plastics they identified take decades to break down, not just something you can relatively easily break down like the polyethylene can be. This then brings us back to the original point of dose and poison. What exactly is it? Is it causing a problem? And if it is going to cause a problem, at what amount? And we simply don't know. This is why the claim, although a worrying headline, is by itself rather meaningless. We simply don't know what the implications are. There is another study this week that is far more, let's say, definitive, and also, at the moment at least, equally as useless. That is, the Y chromosome is shrinking, although it's also described as degenerating. You have no worry that in the near future this will happen. At the current rate, it's expected to take a few million years, so we're more likely to go extinct due to, for example, viruses, global warming, a desire to go beyond our own planet and pissing off an alien species than we are to actually see the Y chromosome go away before humanity does. But it does raise the question of what would happen if the Y chromosome actually disappears and humanity was alive to see it. And the conversation does provide something of a, let's say, explanation as to what could happen. Admittedly, what they provide as far as explanation goes doesn't really help. It looks more like an apologist piece about sex chromosomes and the fact that the Y chromosome doesn't tell you if you're a male or a female. Nevertheless, it is at least somewhat helpful. It's not so much helpful for humanity in the distant future. Rather, it might be helpful now in terms of things like sex reassignment or however you wish to call transitioning now. The reason it's useful is that we can look to other species that have no Y chromosome, and those that are at least a mammal, and we can, to a certain extent, learn from them. In these cases, what they have is either one copy of the X chromosome or two copies, and therefore don't necessarily require the Y chromosome to survive for the most part. The reason these rodents can get away with it is that they carry certain genes that will activate or deactivate as required depending on which particular sex the rodents are. As a result, it is entirely possible to have a sex-determining gene rather than a chromosome. Shifting again to other news, but this time news that's kind of painful to admit to. It's a retraction notice, and it's all related to an article called Serum Bilirubin Levels in Primary Sorgan Syndrome and Associated Interstitial Lung Disease. The article was published in BMC. BMC is a well-recognized and generally a quite reputable journal. However, as the editors write in the retraction notice, they managed to screw up. They describe it as an administration error, but nevertheless, it's a screw-up, and the article was published before peer review went through. This is very, very unusual, and it's why it's worth mentioning this week. Somehow or other, some poor desk jockey has managed to push a button approving it to be published before it was ever looked at by people who should look at this before publication. And as a result, well, the, analyses that were conducted, and shouldn't have been conducted the way they were, ended up allowing it to be published. But as noted, it has been retracted, and even the authors agreed to it, which is, frankly, rather unusual. Most authors will fight very hard, at least initially, to keep an article published. Going to Nature now, not the journal though, rather actually Nature, we have what is not particularly important news, but just more interesting and awkward. A video of humpback whales engaging in, homosexual sex. It takes the name humpback quite excessively. The news itself isn't really all that important. Most species out there have at least some proclivity towards being homosexuals, and although maybe not as prevalent as it is in humans, it's not uncommon. What is, useful or interesting here is, partly the fact that they've recorded it, which does seem somewhat perverse, but also that they've just proven another species does engage in this behavior, which is interesting, but again, not particularly important. In further animal-related news, we have the claims that there are now 2 species of the Anaconda. Now, this is a study that should be taken with a considerable amount of salt, largely owing to the fact that the entire basis for the claim that there are now 2 species rather than 1 is that there are some genetic differences between different snakes. Well, yeah, that shouldn't surprise anybody. If you take 2 humans and put them side by side, you're likely to see genetic differences. It's the degree to which, and ultimately the fact that there doesn't seem to be, at least in our opinion, a justifiable distinction between the genetic differences. They don't appear to be especially distinct, but the authors have argued that because you now have 2 seemingly distinct differences, up to a 5.5% difference, so yeah, the conservation of the species needs to be more carefully examined. Now, to be clear about this, and we've said it before, the distinct differences between inter- and intra-species are more significant interspecies than they are intra. That is a more complicated way of saying, if you were to take 2 humans and put them side by side, there would be far more differences in their genetic composition than there would be if you were to compare a human and a monkey. This is the key thing here. Yes, there's a 5.5% difference, but by comparison to other species, it's much higher. But then again, when you compare other species to their own contemporaneous members of the same species, you lose some of that significance. In fact, arguably, you lose a lot of that difference and a lot of that significance. A very important distinction that appears to be overlooked a lot in what they talk about in this article. Moving to agricultural news, and we have that Rwanda is endorsing and embracing GMO potatoes. In fact, potatoes as a general product in Rwanda are incredibly important. They are a staple crop. But, unfortunately, they also have the same issue that most people who rely on potatoes have: pests, disease, and environmental change. This leads to massive losses for farmers. In fact, we've encountered this before, at least in the West, with the Irish potato famine. Because of that, you can look at this and go, GMOs are needed because we don't want Africa going through a shit show again, let alone Rwanda, who's already been through a lot of problems historically. The other benefit to this is in the headline to the article. That is, bees in Rwanda, unfortunately, are to a certain extent a collateral damage in the attempt to suppress all of the problems that their potato agricultural sector has. Fortunately, because of the attempts to protect the potatoes, which can have between 60 and 100% of loss in each field, farmers are rather aggressive in their use of things like pesticides and herbicides. The consequence of this is that, well, bees get killed, and this means that the Rwandan bee population is dropping at an alarming rate. By using GMO potatoes, the need for pesticide use decreases substantially, and as a consequence, the bees will be protected because you don't need to use pesticide anywhere near as much. And of course, it's not just bees that'll be protected, other species too, but at least in terms of food security, bees as a pollinator in Rwanda are perhaps a major player that needs to be noted. Going to what is to a certain extent the environmental aftershocks of 1945 and the bombing of Hiroshima. The nuclear bombing of Hiroshima, although allowing for the pithy quote, "I have become the destroyer of worlds," also has results that are more relevant today, and not just in the fact that, well, we have the peaceful atom, that being the project to turn the weaponization of nuclear weapons into nuclear power, but actual tangible things that are helping us today, which is weird to say. After 70 years, scientists are looking at the debris and fallout from the bombing, where there are tiny glass spheres thrown onto an island away from Hiroshima. The island and the beach that it is on are called Motogina. It's a small island in the Hiroshima Bay. What's important about these tiny spheres is that they are, or at least were, made from concrete and steel. Concrete and steel that was Hiroshima's buildings until they were vaporized by a nuclear bomb, then thrown up into the air, and then fell down after the extreme heat. As they fell back down to Earth, like with a shot tower, they formed small round balls. These are almost like a bead. By analyzing these, scientists are able to understand not just the consequences of a nuclear bomb, but importantly, they're able to figure out whether or not chondrocytes, which are asteroids from space that have fallen to Earth and therefore become meteorites, and some of the, let's say, early solar system developments. That is how our planet, and for that matter, the other planets in our solar system, were formed. The reason this is distinct and important from other methods of approaching this owes to the isotopes that are involved. Where most isotopes are fairly well known, the distinct one here is oxygen-16. It's a form of oxygen with fewer neutrons, and therefore it is somewhat lighter than the typical form of oxygen you would imagine. As a result, these are unique and very obviously practically impossible to recreate outside another city being bombed with a nuclear weapon, which is possible but hopefully not going to happen. The other way to do this is by using UV light, and by setting up an artificial environment, scientists can demonstrate that you can create the isotope of oxygen this way. This, of course, is all based on the idea that you can, let's say, compare the bombing of Hiroshima to the accretion disk that started our solar system. Hopefully, we don't actually have to experience this again, since we're not yet ready for a Fallout-type universe. Going to technology now, and what could be the beginning of a, let's say, Terminator-type universe. A company has claimed that its AI has successfully replaced the role of about 700 people. Admittedly, 700 people that the company laid off about a year ago, which isn't exactly a, let's say, a popular statement or claim to be making at the moment. The Swedish finance company called Klarna announced that its AI had been able to automate a lot of work and so take over the role of 700 employees. About a year ago now, when they first announced this AI, they also happened to lay off 700 humans. Somebody might immediately jump to the conclusion that the two are the same, which isn't quite right. Admittedly, the claims are related in that they share a common number, but the company can't have been certain a year ago that they would have been able to do so, particularly given that at the time the 700 individuals represented about 10% of its workforce. Admittedly, those people won't ever find their job again now, but still. And this is the issue though. The crux of the problem is that people are looking at the intersection of the ability of the AI to fill in the roles of these individuals and the fact that this is likely to be seen increasingly in other places, and not just this one company, and that it does raise a question about the long-term impact of, quasi-AI to be honest, not actual AI, and human occupation. And not just occupation of the job, but just sheer ability to be employed regardless. Going to space now, and more physics news than anything else, it's the ability to predict where a planet will be based on figuring out where water should show up. Now, this may not seem like an obvious relationship, but it's what happens after this that is key. The physicists and astronomers were looking at where they would expect to see water forming, and the reason they're looking to see it where water would be forming is that it should be the same place where planets are beginning to form, explaining where Earth got its water from, and arguably where places like Mars and even the moons around Saturn and Jupiter got their water from when those planets were forming. The imaging of far-off stars has found that there is water vapor at a distance from the star that should fit just neatly into where a planet could and probably is forming at the moment. Although forming is perhaps a rather generous word given how long it will take, it's more like a slowly, grudgingly, and very unwillingly getting there eventually, somehow, somewhen. In other star-related news, although this time much closer to home with our own star called Sol, it's what happens with the clouds in our atmosphere when a solar eclipse occurs. Now, presuming that it's not a solar eclipse caused by the attempt to summon some sort of eldritch being who's very angry with interrupting its sleep, it's more likely to be a natural phenomena. Those natural phenomena, however, do have some bizarre quirks to them, one of which is what happens to all the clouds. Now, to be clear, not all the clouds in terms of every last cloud in the sky, otherwise we'd never complain about the inability to see a eclipse. Rather, it's what happens when there's certain clouds that are important to this study that seem to disappear. And that's the weird thing here. Somehow, during an eclipse, there never seems to be a problem with clouds in the right circumstances. And, as the study explains, if we're going to look at geoengineering through things like cloud seeding, or more likely to be blocking the sun to some extent, we need to know what's happening. Because if we don't know that, we can't exactly do this. Sure, we could seed clouds, or we could try and put clouds up to stop climate change and global warming, but then the moment we get a solar eclipse, all that work is undone. Well, what the researchers found is that cumulus clouds practically disappear once you account for about 15% of the sun being covered, which is your standard lunar eclipse. And this can be rather important, as unfortunately, before now, there hasn't really been the accounting for the effect of a lunar occlusion of the sun. And because of this, most assessments of cloud coverage have been at least somewhat, let's say, overestimating or underestimating, due to that flaw, just how much cloud coverage there is. What they think has happened is due to the blockage of the sun's light and the consequential change in how much warmth makes its way to Earth, the let's say clouds, due to the lack of heat, don't have the updraft, and because they don't have the updraft from that heat, the clouds, particularly in the form of cumulus clouds, can't be sustained. Now, as mentioned, this isn't necessarily important now, but in the relatively near future, when we start to geoengineer, it could well be. Shifting to news that's very current and won't be current again for another 4 years, we have the fact that, Earth undergoes a leap year, or more accurately a leap day, every 4 years, creating a leap year. And the question of what would happen if we didn't actually do this? What would be the effect of ignoring that extra day every 4 years? And surprisingly, there's actually a fairly good answer from the conversation. To be clear, it's a good answer, but it's not perfect. The short version is that we basically find ourselves in the same place that a lot of other groups do, whether it's religious or cultural groups. Their activities end up slowly having their various events shifted around each year. Sometimes this is only a mild change of a day or two. Other times, it's a lot more than that. In fact, it can be a week or more, and every year that event gets pushed back even further because it doesn't account for the change in the solar calendar. These groups generally rely on something like the lunar calendar, which does make sense if they're only using 12 months for their lunar calendar. If they used 13, it really wouldn't matter. But what is interesting is the explanation that, in fact, most groups have historically known about this, recognized it, and tried to fix it. For example, Rome, and rather notoriously Julius Caesar. Julius Caesar was at one point responsible for ensuring that the Roman calendar, which shifted somewhat due to the nature of how they kept their calendar, was adjusted correctly, and due to the various uprisings when he crossed the Rubicon, he was able to do so and ensure that certain events happened the way he wanted to, because he was responsible for maintaining their calendar, and therefore, by not doing so and causing the unrest that he did, he could actually create a lot of problems in Rome. In this case, we don't have that problem so much, as we have a fairly standardized calendar across the world for most purposes, and it's fairly robust. A part of that robustness is down to the fact that there is a single day added every 4 years. Finally, we have the last piece of news for you, and that is that Odysseus has fallen over, or the lunar lander has fallen over. Thankfully, the payload appears to be fine. The good news is the actual lander itself is still able to transmit, so we've not lost it as such, it's just really, really drunk. It seems like part of what happened leading to this situation is that one of the laser rangefinder's locks had not been disabled, seemingly back when it was on Earth, and because of that it was unable to accurately measure its travel distance and similar, and therefore compensate. Now the company responsible was able to gerrymander the NASA equipment on board to compensate for this, but as noted, it obviously wasn't a perfect solution. And then again, to have any kind of solution like this in about 90 minutes is impressive, so all the more credit to them for it. But still, the lander itself has clearly not been able to stay upright. Of course, this is one relatively minor hiccup when you consider what's been achieved, remembering that Odysseus is a lunar lander that has been delivered to the moon by a private company. And not just is it a private company, but it's the first time that America has been back to the moon since the 70s. The other issue here is that, the lunar lander is basically like a child whose dad's gone out to buy cigarettes and milk. After about 9 or 10 days, it's basically going to be abandoned there, after it freezes to death, unfortunately. The batteries and other systems on board are unlikely to be able to keep it alive any longer than that, partly owing to the sheer cold of the moon, but the other issue is that half of its solar array is simply not able to get light. Because of all of this and the other issues, it doesn't have much longer left. That's all the news we have for you this week. Thank you for watching. If you found it interesting, consider liking, sharing, and subscribing. Please do post any comments, questions, or suggestions you have below.